Okay, simultaneous equations. I called it something else when I was younger. It freaked me out when I saw this, but this isn't too bad. This is like substitution and subtraction and things like that. We can do this. This isn't too bad. What we're doing is we're trying to find we have two equations and we're trying to find where they are on a graph, where they touch, basically. Okay? We can do this. Going through the example, solve the simultaneous equation. So we have 2x equals 6 minus 4y and -3y equals 4x. We rearrange the equations so they're in the way that we know. ax plus by equals c. So our first equation is going to be 2x plus 4y equals 6. And our second equation is going to be -4x -3y equals 3. What we have to do is we have to figure out how we can basically get rid of either an x or a y. Because once we can solve for x or solve for y, then we can substitute it back into the other equation and solve. So we need to first find what x maybe equals or y, and then we put it back into the equation and we can solve it. So in this example, they are suggesting that we change the coefficient of our x so that it's a 4, and that way we can subtract or add these two together, get rid of our x's, and we'll solve for y. Okay, here we go. Let's walk through this. So what that means is I'm going to take my equation number 1, this one, and I'm going to change it a little bit. I'm going to multiply everything by 2 so that my coefficient of x is going to be the same as my other equation here. So 2 times 2 is 4. As a matter of fact, I'm going to use a different color so you understand this is sort of my new equation. So now 2 times 2 is 4x. 4 times 2 is 8, positive 8, and it equals 12. So this is actually this. It's the exact same thing. I've just made it grow by 2. Whatever you do to one term, you have to do to the others. But now if you have a look, now I could actually subtract one of these from the other or add them. You can add or subtract. What you want to do is you want to eliminate. So I actually have a negative here, and this is a positive. So I'm going to add them. I'm going to write add. I'm going to add these two formulas. Why? So I get rid of one variable. So -4 add 4 is 0, right? So now I have 0x. It's like it doesn't exist. Oops, I forgot to write my y. My apologies. Now I'm going to add the next ones. -3 add 8. So if I have 8 and I take away 3 from it, that is positive 5y. I'm going to add my c's here, the last term. 3 plus 12 is 15. Now we have y, 5y equals 15. I want to isolate y, find out what y is. So I'm going to divide it by 5, which gets rid of it here. But whatever I do to one side, I have to do the other. So now y equals 5 goes into 15 3 times. I found out what y is. Now I'm going to substitute it back into one of my original equations. It could be either one. It doesn't matter. I'm going to pick the first one. So I'm going to say 2x plus 4, and I'm putting it right in there, equals 6. 2x plus 12 equals 6. I want to get x all alone. So I'm going to say 2x. I'm going to minus 12, but whatever I do to this side, I got to do to this side. So 2x now equals negative 6. Now I'm going to divide this by 2 to get rid of that, so I only have x, but I have to divide this by 2. Negative 6 divided by 2 is negative 3. So now I know that my y is 3 and my x is negative 3. I now have solved for x and y. And that's it. You're done.